For over a century, physics has been governed by one beautiful, unyielding rule. It comes from Albert Einstein's brilliant mind. He told us that there is a cosmic speed limit, a maximum velocity that nothing in the universe can exceed. This ultimate speed is the speed of light. Imagine a beam of light, a photon, racing across the void. It travels at an astonishing 186,000 miles every single second. This isn't just a suggestion, it's a fundamental law of nature. It's the universe's ultimate highway speed, and everything with mass is destined to travel in the slower lanes, forever chasing a speed it can never reach. Why is this speed limit so absolute? Einstein's theory of special relativity explains it with profound elegance. As an object with mass, like a spaceship or even a tiny particle, begins to accelerate, its mass increases. The faster you go, the heavier you get. This effect is minuscule at the speeds we experience on Earth, but as you approach the speed of light, your mass starts to grow exponentially. To reach the speed of light itself, your mass would become infinite. Pushing an object with infinite mass would require an infinite amount of energy, which is more energy than exists in the entire observable universe. Think about the most powerful rockets we can build today. They burn incredible amounts of fuel just to escape Earth's gravity and drift through our solar system. Even our fastest probes, traveling for decades, are moving at a tiny fraction of light speed. The Voyager 1 spacecraft, our farthest messenger, travels at about 38,000 miles per hour. That sounds fast, but light could circle the Earth more than 7 times in the blink of an eye. The vast distances between stars make interstellar travel seem like an impossible dream, a journey that would take tens of thousands of years, all because of this unbreakable light barrier. So the dream of zipping between galaxies, of visiting alien worlds in a single lifetime, seems to be a fantasy. Traditional physics, the very framework that allows us to understand the cosmos, puts up a giant do not exceed sign at 186,000 miles per second. It tells us that no matter how advanced our engines become, no matter how much fuel we burn, we are fundamentally stuck. We are inhabitants of a cosmic neighborhood, with the rest of the universe locked away behind an impassable barrier of time and distance. But what if we've been looking at the problem from the wrong angle? What if the secret isn't to go faster, but to change the road itself? Let's imagine a different way of thinking about the cosmos. This is where a new idea, let's call it quantum physics, comes into play. This theoretical framework starts with a radical proposition. What if the vacuum of space isn't truly empty? We often picture space as a vast, black nothingness, a passive stage where planets, stars, and galaxies perform their cosmic dance. But quantum physics suggests that space itself is a dynamic, tangible medium. It's a fabric woven from the fundamental energy of the universe, something that can be stretched, compressed, and manipulated, much like a sheet of rubber. This idea changes everything. If space is not a void but a substance, then it might have properties we are only beginning to understand. Think of it like water. A fish swims through water, but the water itself can flow, form currents, and create whirlpools. In this new view, space is not just the where, but also the how of movement. Quantum physics proposes that this quantum foam of spacetime is filled with latent energy. This energy doesn't just sit there, it holds the potential to be shaped and molded if we can figure out how to interact with it on a fundamental level. How would one go about shaping space? According to this theory, the key lies in the relationship between energy and gravity. We know from Einstein that massive objects like stars and planets warp the space-time around them. This warping is what we experience as gravity. It's a gentle, large-scale curvature. Quantum physics speculates that by using immense concentrated bursts of energy, we could create highly localized and intense gravitational fields. These fields wouldn't just gently curve space, they could actively reshape it, creating temporary tunnels or corridors with entirely different physical properties. This is a profound departure from our classical understanding. We are no longer just passengers traveling through a static universe. Instead, we become cosmic architects, capable of altering the very medium we travel through. The challenge, of course, is monumental. It would require a mastery of energy far beyond our current capabilities, a way to generate and control forces on a scale that could influence the fabric of reality itself. But the concept opens a door that was once firmly shut, suggesting that the limitations of the universe might be more flexible than we ever imagined. The empty space between stars might just be the most interesting thing out there. So how does changing space allow a ship to break the light barrier? The trick is that the ship itself never actually moves faster than light within its local patch of space. It's a clever cosmic loophole. Imagine you are standing on a rug. To get to the other side, you could walk across it, or you could have someone grab the far end of the rug and pull it towards you. You haven't moved on the rug, but your position in the room has changed dramatically and quickly. This is the central idea of breaking the light speed limit with quantum physics. The spaceship stays still while the space around it does all the work. Let's put some numbers on this fantastic idea. In normal space, the top speed is a firm 186,000 miles per second. But inside one of these specially created corridors of altered spacetime, the rules are different. By using tremendous energy to manipulate gravity, a ship could compress the space in front of it and expand the space behind it. This creates a warp bubble. Inside this bubble, the ship is safe and stationary. But the bubble itself, carried along by the wave of contracting and expanding spacetime, could move through the universe at an effective speed of, say, 511,500 miles per second, nearly 3 times the speed of light. This method completely redefines our use of energy and gravity. Traditional rockets use energy for propulsion, pushing the ship forward through brute force. In this new model, energy isn't used to push the ship, but to manipulate the gravitational field around it. Gravity is no longer just a force that pulls you towards a planet, it becomes a tool, a sculptor's chisel used to carve pathways through the cosmos. The ship's engines would be focused on generating and sustaining the warp bubble, a task requiring unimaginable power, but one that obeys a different set of physical principles than simple acceleration. This concept bears a strong resemblance to the warp drive seen in science fiction, like in Star Trek. However, there's a key difference. Many sci-fi depictions are vague about the mechanics, often treating it like a magical hyperdrive. Quantum physics, while theoretical, attempts to ground the idea in a plausible extension of our current understanding of physics. It doesn't ignore Einstein's laws, it finds a creative way to work around them. The ship never locally breaks the speed of light, so the paradoxes of time travel and infinite mass are avoided. It's a more disciplined, thoughtful approach to one of humanity's greatest dreams. Why does this idea, even as a far-off theory, matter so much? It represents a fundamental shift in our cosmic perspective. For all of human history, we have been bound to our home world, and more recently, to our solar system. The stars have been beautiful but unattainable points of light. The sheer scale of the universe has made us feel small and isolated. The possibility of faster-than-light travel, enabled by manipulating space-time itself, transforms us from passive observers into potential cosmic explorers. It turns the galaxy from an impossibly large ocean into a navigable sea, with new worlds and new discoveries waiting on distant shores. This concept ignites the imagination and fuels the scientific drive for discovery. It suggests that the answers to our biggest challenges might not lie in refining old technologies but in discovering entirely new physical principles. Exploring quantum physics would push us to understand the nature of dark energy, the mysterious force causing the universe to expand. It would force us to probe the relationship between gravity and quantum mechanics, one of the greatest unsolved problems in all of science. The pursuit of this knowledge, whether it leads to a warp drive or not, will undoubtedly unlock countless other secrets about how our universe works. Of course, the path forward is filled with enormous, unanswered questions. How much energy would it actually take to create and sustain a warp bubble? Current estimates suggest it might require the energy equivalent of an entire star, or perhaps even more. How could we generate and control such power without destroying the ship and everything around it? What exotic forms of matter or negative energy might be needed to make the theory work in practice? These are not small engineering problems. They are deep, fundamental questions that challenge the very limits of our scientific knowledge. Ultimately, the dream of warp speed is more than just a desire for faster travel. It is a reflection of our innate human curiosity, our unyielding desire to reach for what lies beyond the horizon. It's the same spirit that drove early navigators to cross oceans and astronauts to walk on the moon. While quantum physics and warp bubbles remain on the drawing board of theoretical science, they serve as a powerful inspiration. They remind us that the universe is vast and full of wonders, and that the most exciting discoveries may still be waiting for us, nestled in the very fabric of space and time.
Quantum physics theory replaces relativity's time-based limitations with spacefield dynamics. As time ceases in our ship at light speed, it continues in the ship. A space bubble is created around the ship at its fastest medium velocity. In the infinite energy concept explained in relativity theory, Einstein asserts no more propulsion equals C2 can be achieved. But if we look at this as a passive travel continuum, energy for propulsion can raise to a higher potential if engineering designs are greater or bigger. A bigger engine or warp drive. If the speed limit is based on gravity and it is which compressed energy conservation in a zero vacuum and possible negative field vacuum that is yet to be discovered as a physical source. Space travel can exceed surpassing the energy speed limitation with a higher warp drive motor. Einstein's universe speed limit EMC is squared.